This is a video about exponential functions. First, I want to have a look at how to graph exponential functions. An exponential function is a function that looks a bit like this. We've got f of x equals 2 to the power of x here. And you can see that our variable, x, is up in the power. Now, another word for power is exponent. And when you have your variable in the exponent, that's what makes it an exponential function. So let's say that we're asked to graph this function in the domain -1 up as far as 3. So first of all, we go to the calculator and we go into our function setting, and then we want to type in 2 to the power of x because that's our function. So we'll press 2 and then we'll press the power button, and then we'll press alpha to get the x in and press equals to register. Some calculators might ask you for a second function, g of x. I don't have one, so I'll press equals to get past that. I want to start at -1, so I'll put -1 in for my start value and press equals. I want to go as far as 3, I'll press equals, and I'll go up in steps of 1. And again, as normal, I can see my table here. And so these are the values that I'm going to use for my graphing, and I'm going to write these values on the page now. Okay, so I've got my table there replicated from what I would have in my calculator. And then it's the same as usual for graphing. We graph the points onto our xy plane and join them together to make the function. So here I have my xy plane, and you can see here that I've really focused on the region above the x-axis. And that's because generally we'll find with exponential functions that our f of x values will tend to be positive, particularly if we've got a positive value here as our base. So in this example, we can see that f of x is always positive. So our function is going to be positive. It's going to be in the positive region of the graph above the x-axis. Okay, let's mark in our points. And we're then going to want to join those points together in a nice smooth curve. And so my function should look like this. Now I've stopped at the two end points, but as with all functions, you could keep going past those points. And it's just interesting to note what happens on either side of my function there. As I move further to the right, it gets steeper and steeper and steeper. And as I move further to the left, it gets closer and closer to the x-axis. But what's very important to understand is that it never actually touches the x-axis. So you can bring this curve down really, really close to the x-axis, but they shouldn't touch. And there's a particular word for this. We can call the x-axis an asymptote of the function. So this just means that the function, the curve, gets really close to it, but never touches it. Looking at our graph again, notice how this function goes through the y-axis at 1. This is kind of the default y-intercept for exponential functions. We can say that any exponential function written in the form a to the power of x has a y-intercept at 1. But not every exponential function has a y-intercept at 1. So let's look at an example now of one that has a y-intercept somewhere else. So say, for example, we're asked to graph g of x equals 2 times 3 to the x. Just notice the way that this is written here with a dot between the 2 and the 3. This dot means multiplication. You might also see it written like this. So we're going to graph it in the domain -1 up as far as 2. So get the calculator, and we're going to want to enter the function 2 times 3 to the x. Now, we're not going to use the decimal point, so don't go using that at all. It's much better to type it in using the brackets that I indicated here. So 2 bracket 3 power button, and then alpha to get the x, and then arrow to get out past that power, and then close your bracket, and then equals. I don't want another function, and then I want to start at -1, and I'm going to go as far as, oops, I need to go back there for a second, and I want to go as far as 2, and I want to go up in steps of 1. Okay, so now I've got my table, and again I'll recreate that in the page, and then we'll graph. And just before I do that, just to point something out to you, you can see here that my very first f of x value is 0.66666. You might have kind of a bit of a moment when I'm thinking, well, where do I position that exactly when I want to graph? So what you can do, if you like, is you can actually arrow over to that on the calculator. You can see that the value comes up on your screen here at the bottom. And then if you press the SD button, it'll change it into 2/3 view. And so 2/3 might be easier to place than 0.666. So here we have our g of x values, 2/3, 2, 6, and 18. And again, just notice that they're all positive, just like the last time. Okay, so I have my xy plane set up ready to go. I'm going to mark in my points, and there they all are. And then I'm going to join them together in a nice smooth curve again. So I've drawn in my curve. And again, notice how it gets steep really quite quickly here on the right-hand side. And on the left, I've come a little bit behind that -1, just again to show that I'm getting really, really close to the x-axis, but I'm not getting down as far as it. So don't run the curve into the x-axis. Remember, like we said, the x-axis is an asymptote of the function. So the function gets really close to it, but never reaches it. We had said earlier that any exponential function written in the form a to the power of x has a y-intercept at 1. So notice that this particular function isn't quite written in this format because it's got this extra number in front. And when I look at the graph, I can see that this particular function doesn't go through the y-axis at 1, instead it goes through it at 2. And this is related to this number in front. So whenever you're looking at an exponential function, if it's written in function form and you want to figure out where it goes through the y-axis, just see is it multiplied by anything. If it's not, if it's just written in this format, then it goes through the y-axis at 1. But if it gets multiplied by a number at the front, well then it goes through that value on the y-axis. So a function written in this form, k multiplied by a to the power of x, has a y-intercept at the k value, so at whatever that number is there at the start. So again, just to hammer that point home, 2 times 3 to the x has its y-intercept at y equals 2, and it's because I'm multiplying by that 2 at the front. We might also have to identify an exponential function from its graph. So here we have an example of an exponential curve, and we're told 2 points on the graph, but we're not told what the function itself is. We're just told that it's called f of x and that it's written in the form k times a to the x. So we want to find k and we want to find a, and we want to use those to make f of x. Okay, so this is actually pretty straightforward to do. First of all, I'm going to look at the point where it goes through the y-axis. It goes through the y-axis at 0, 4. So that means that where it goes through the y-axis, the y value is 4. What's really nice about this is that whatever that number is that it goes through the y-axis at, that's always going to be the value of the multiplier k. So if I was going through the y-axis at 5, then k will be 5. If I was going through the y-axis at 10, then k will be 10. That's really easy. I just pick that value out. My other point, 216, I'm going to use that for a bit of input-output work. So if I put 2 into this function, I'm going to get out 16. Now, I already know what k is, so I'm going to write down that f of x equals to 4 times a to the x, first of all. Okay? Now I'm going to work out f of 2. So 2 is my input, and it goes in for x. And of course, I know what I get when I put 2 in. I know that I get 16 out. So 16 is my output. And now I have a little equation that I can solve to figure out a. So here's my equation. 4a squared equals 16. So I want to figure out a. So first of all, I'll get the a squared by itself. So I'll divide across by the 4, and that gives me 4. And then I can just square root this to get a. Now, we've spoken before about how you can get positive and negative results for rooting, but actually when we're dealing with an exponential function and we're looking for an a value, it's always going to be positive. So I can just take a equals 2, and I can get that by just typing in root 4 into the calculator. So now I have the k and the a that I was asked for, and I'm asked to hence get f of x, and that just means put the k and the a back into it. So f of x equals to, okay, k comes first, k is 4, times a to the x, and a we figured out was 2. And then we just put the little x up in the exponent because it's an exponential equation, or exponential function if you like, and we close our bracket and we're done. You could also write it, if you wanted to, as 4 times 2 to the x, with a little dot there means multiplication.